Hello, welcome to another session of our open program from 2021, so Knowing Through Sound. Today, the session is Computational Listening with Miguel Carvalhais. Miguel Carvalhais is a designer, artist, musician, researcher, and assistant professor at the Faculty of Fine Arts of the University of Porto. He studies creative practice with computational systems and wrote the book Artificial Aesthetics on this topic. His research and practice explores how computational and procedural systems are read by humans and how procedural discovery and interpretation are paramount for the creation of meaning and the aesthetic experience. His artistic practice spans computer music, sound art, live performance, audiovisuals, and sound installations. He also runs the Chronicle label for experimental music and sound art, the Escola conference on computation, communication, aesthetics, and X, and the Invisible Places Symposium on soundscape, art, and ecology. Today's topic is computational listening. As a conscious activity, listening is receiving information through hearing. It involves identifying sounds and processing them into content. When we listen, we receive sounds and we use our brain to convert these into messages that mean something. The act of listening involves complex affective, cognitive, and behavioral processes. It is a skill that involves different levels of effort. It takes a level of concentration and focus. Listening has a key role in our lives, either in the context of survival or in the cognitive development. For example, it is the first of the 4 language skills, before speaking, reading, and writing. It is the primal form to connect and perceive the surrounding. Listening jumps between different levels of consciousness. To implement a listening ability to computers, since audio signals are interpreted by the human ear-brain system, that complex perceptual mechanism should be simulated somehow in software for machine listening. This notion of teaching a machine to listen was first widespread in the artistic application of computer music. We live in a post-digital world in which an invasive computation is fundamental to how communication functions and becomes essential to artistic practice and aesthetic experiences. Today, our very present digital processes are increasingly able to analyze and respond to sonic information as well. Machine listening is much more than just a new scientific discipline or vein of technical innovation. It is also an emergent field of knowledge power, of data extraction and collisionism, of capital accumulation, automation, and control. It demands critical and artistic attention. Initially, inspired by models of human audition, machine listening deals with questions of representation, transduction, grouping, use of knowledge, and general sound semantics for the purpose of performing intelligent operations on audio and musical signals. Artists contribute to the ongoing process of thinking and questioning ourselves and the world through the engagement of artwork tools and art directly in roles with those technological practices, primarily as a way to understand how they affect us, and finally, as a means to reorganize ourselves. Computation is capable of endlessly generating new environments, not because the technologies are new in themselves, but because it allows the permanent rearticulation of environments and the constant development of new and sometimes unprecedented relations with their inhabitants. In a wider vision, computation is no longer only a means to create an artwork, but can be the artwork itself. But we are in a new step of this ongoing process. The focus is not longer about mechanic simulation or auditory process. Nowadays, the ways of listening are going through a new reconfiguration pushed by the ubiquitous presence of computers, computer networks, and computational media in our lives. Immersed in computational technologies, our listening needs to adapt to online and offline environments marked by an all-out internet condition that turns culture into a code space. In this talk, our guest will explore how human perception is reconfigured by the computational, becoming multi and cross-modal, making sound and algorithmic listening fundamental epistemological resources for both audience and creators alike. Miguel, thank you.
Thank you.
The stage is yours.
Okay, thank you. Thank you, José Alberto, for the introduction, and to you, Andio, for the invitation to be here. And thank you to the School of the Arts for putting this program together. So my name is Miguel Carvalhais, and I'm going to talk about listening and sound and art and computation, more or less in the reverse order. Starting from computation, computation is a very encompassing term where I include computers and computer networks, of course, but also computational media, computational arts, computational aesthetics, and all the computational objects within this. I find that computation has been so ubiquitous and so important in our recent and not so recent past that it has been reconfiguring our human perception and has a very strong transformative effect in our artistic practices, and not only in artistic creation, but also in artistic or aesthetic pleasures, which are also artistic practices in a sense and are as fundamental to creation, as fundamental as creation, and far more abundant than it. So we live surrounded by computation. We live immersed in computation. We live in a post-digital world that is subsumed to what Catherine Ailes calls the regime of computation. And in here, computation is not only central to art and to artworks, as it is central to the aesthetic experiences that we have with this. Because computation is everywhere. It's in our tools, it's in our media. It may exist within an artwork. It may be used to develop or to create an artwork. And even, and this is what mostly interests me, computation can be the artwork itself. So much in the same terms as Henry Flint described conceptual art in the 60s, art of which the material is concepts, as the material of, for example, music is sound, we can think about computational art as an art of which the material is computation. But what is this then? We should perhaps try to very quickly start by trying to define this. A computation is any process that obeys finitely describable rules. It's a process where calculations or any other processes are performed in accordance with a rule book that is well-defined, with algorithmic models that are well-defined and that are finite, meaning that we have a closed set of instructions. Okay? And that's all there is to it. Of course, this definition doesn't fully describe our automatic computing engines, the ubiquitous and semi-autonomous Turing machines with which we populated the world, but it describes their central operational principle, the deployment of processes that obey rules that are describable in the first place and that are finite. So, to compute is then to count, to calculate, to manipulate information. And computation may happen across many frameworks. With digital computers being only one of the platforms where computation can happen. So computation can take place in a large variety of media and with almost any kind of material substrate, actually. So we should be careful to note, too, that when we talk about computation, most often we are not describing the actual physical process. We are, the physical process of computation may happen using sprockets or using relays or using switches or transistors or, ants or even neurons in our brains. But when we talk, or when I talk about computation in this context, I'm more often than not referring to the abstraction of these processes. Because regardless of how we execute the computation, regardless of this physical material substrate that actually does the physical work, a computation or the abstraction of that computation is always the same. And in spite of the variations in their underlying structure, there is an equivalence between minimally complex computations that allow them to exhibit the same level of complexity, of computational sophistication across systems. And keep this in mind because we will return to this idea of equivalence. So, it doesn't really matter if we have a digital computer like this one, or if we have an analog computer, if we have a biological system or any other physical system. If they are computing, that computation can most likely be abstracted and emulated. So, computational artworks then are systems where computation is not solely used to create form by describing structures and processes, but they are systems where computation also becomes one of the aesthetic outputs of the work. Sometimes a fundamental aesthetic output, the essence of the artwork. So, in spite of this, computation itself does not need to be enacted by the artworks or by the medium of the artwork. We can find several works that are deployed in classical media and that apparently are non-computational and that can be found to have a very high process intensity because they have access to humans, human readers, human users, human audiences, and humans can process information in the works and can enact computation. So this means that instead of enacting the processes themselves, the artworks can actually defer that to humans by offering them the medium or the means, better said, to deploy computations. And this usually means conveying them relevant data and relevant instructions or code. And a very quick example, and probably one of my favorite examples of this case is this book by Raymond Queneau, 5000 milliards de poèmes, which apparently it's a very simple classical-looking book containing 10 poems with 14 verses each poem, so 10 sonnets. The only odd thing about this book is that it's slightly unconventional page format, because each of the pages is cut in 14 strips that allow, in a way that allows each of the verses to be combined with every other verse, which brings the potential number of different poems that can be generated with this book come to 10 to the 14th power, hence the title of the book. So, what is the reader of this book supposed to do? The reader is not supposed to read the 10 printed poems. Those are, they are, let's put it, they are possible poems within the phase space of the book, but they are the least interesting possible poems in that phase space because they are the ones that were not manipulated. On the other hand, the reader is not supposed to read 10 to the 14th different poems because that effort would require many lifetimes. So what the reader is expected to do in a work like this is first and foremost to compute. The reader is supposed to use the physical and the textual affordances of this book to create new poems by shuffling the verses. And then, once these new poems are formed, I can read them. I can read them whenever they are formed and just before they disappear forever. So, the definition of computational art covers not only physical artifacts with their paratexts and subtexts, but also these abstract machines where processes may be deployed by humans, they may be deployed by digital computers or by other machines or systems that are able to process information. But before continuing with art, let's just quickly go back to computation, because there are a couple more important concepts that we should cover before moving on. And the first of these is the concept of universality and of universal computers. and this is something that we could, of course, discuss for several hours, but to simplify it, let's just say that because of that equivalence I mentioned earlier, a feature of any computational system that is minimally complex is that given the right conditions, they should be able to emulate any other computational system. And what does this mean? It means that if a computation is a machine that develops a given function by following a number of rules, what we usually describe as a program, because of this computational equivalence, there are machines that can be programmed to operate as other machines. And these machines that we call universal computers, universal machines or universal Turing machines, because Alan Turing was the first to actually describe them, these machines have the power to compute the same processes as other non-universal computational machines. This means that they can calculate the same outputs for the same inputs. But it goes further than this, because if they just did this, they would actually only be simulating them. Being universal means that the machine effectively emulates the original computational process, to the point of not only replicating its results, but also the entire computational process. Again, the abstracted process, not the actual movement of the gears or of transistors, etc., but the computational processes through which information is processed. Now, these machines, these universal machines, once programmed, behave as the machines that they are emulating. And as behavior is computation, and computation is behavior, from a computational point of view, universal machines actually become other machines. So, the second idea is the idea of universal computation, not universal computers. And this is the idea that computation is not limited to, digital computers, automatic computing machines, or to this realm of silicon and binary code. Actually, we can think of any process that follows rules, regardless of the element it involves, as being a computation too. And Stephen Wolfram, for instance, suggests the ontological leap of looking at systems in nature and noticing how, in spite of their different physical or biological behaviors, they are strikingly similar in the patterns of behavior that they demonstrate. And that these patterns share behaviors with digital computational systems. So Wolfram suggests that there is a universality of computation that manifests through a very large number of underlying rules, and that extends from simple programs produced by humans all the way to systems in nature. As such, everything in the natural world can be regarded and can be studied as being computational, or as being the outcome of computational processes. And these, according to more recent work by Wolfram, includes things as time, as space, as the standard model of physics, etc. This threshold of complexity that allows any computational system to be universal also seems to be low enough to be extremely common in these naturally occurring computations. So there may be reasons to believe that many of these naturally occurring computational systems, perhaps even the majority of them, may also support universal computation, meaning, again, that they can emulate each other. So the third aspect is irreducibility, because computations are, of course, strictly deterministic because they follow a closed set of rules. And this means that any future state of a computation is non-random and is determined by the interaction between its rules and its input and its current state. So a computation, any computation, is a deterministic universe where once a starting configuration is determined, its laws will dictate what will happen next. As such, randomness is never experienced in computation, and we are limited to, at the very best, programming pseudo-random functions. However, this determinism doesn't imply that all computations are predictable, because many computations can yield genuine surprise. And and can be therefore impossible to predict. This happens because although they are deterministic, they are also irreducible. And this means that it's not possible to devise any computation that provides a shortcut to the behavior of the computation, to the irreducible computation. There's no way to shorten the outcomes, and the only way to know what a given computation will produce is to actually wait for it. Wait until it reaches the end state, or whatever state we're looking for. We are limited to waiting for the computation to unfold. So we know that the computation will inevitably bring us to a deterministic outcome, but we are incapable of foreseeing it. And as with universality, the threshold for this irreducibility is not very high. And once a computation crosses it, it becomes, paradoxically deterministic, while at the same time able to generate outputs that surprise us, and where we are able to perceive novelty, genuine novelty. So, unlike those systems that are obviously simple and that are permanently caught in their past, in the past of predictable and formulaic repetition, complex computations become black boxes. They become irreducible and impenetrable substances that have physical and cognitive prehensions and that are deeply metaphysical. Irreducible and unpredictable computations become a channel for the future. And lastly, and because of this, as our technologies and our media computation is brought to the center of our lives, it helps to shape a new way of thinking that is structured on the understanding of computation itself. So it causes yet another ontological shift that leads to what we may describe as computational thinking. Due to the ubiquity and the pervasiveness of the computational technologies, computational thinking becomes something that is necessary not only when we program or design technologies, but it becomes a fundamental tool for understanding our technology-infused world. So as a consequence of this, we start reconceptualizing our world by computerizing also aspects of the non-digital. And this is the process that Levmanovich calls of transcoding. And is a process that continuously spawns new technologies, that generates new knowledges and methods for our control of reality. So computational thinking then is defined by the set of mental skills, but also the practice of designing computations on one hand and explaining and interpreting the world as a complex of information processes. And this is a useful and concise definition that covers some of the fundamental aspects that we will need to expand on. So, computational thinking happens at this intersection of mechanical and natural computational spaces, but also the intersection with cultural systems and with our own human cognition, allowing us a deeper understanding of not only the computational systems and technologies, but also about the ways how they are shaping the world. And we can trace this idea, actually, historically, to ancient rituals, for instance, and to procedures, and to the incorporations of algorithms in mathematics and in several other processes. So if we look at the history of computational thinking, it goes way back. But a modern understanding of computational thinking mainly deals with the mechanization of cognition within digital computers, within digital technologies, but also within that space where they interact with us. So computational thinking is then about thinking collaboratively. It's about this promise of a collective intellect that is brought into effect by computation and by computational technologies. It may be mediated by technology, and through that, new modes of knowledge can be facilitated. But as in many other aspects of this computational domain, this form of collective thinking is also not necessarily anthropocentric, or at least it's not limited to us humans. So computational thinking implies understanding and accepting the actual limits of computation. It implies accepting the uncomputable, the irreducible. It implies coping with unknowing and with the mystery of the futural. And how these two can reveal some sort of a computational sublime that may not have many points in contact with our thinking, with our human thinking, and with our human consciousness. And in such cases, resorting to phenomenological and behavioral analysis may give us some entry points to grasping the essence of any computational system, particularly computational artworks, and of what we may call computational agency. So computational thinking is therefore central to the development of the computational gaze on which the aesthetics of computation hinge. And finally, just two very short notes regarding the fact that computations are time-based phenomena. We should keep this in mind, and that they are contexts for the organization of events in time. Computation happens in time, and within computational spaces, of which we will talk more soon, computation is time. The cycles of computation exude time, and the computation itself is a phenomenon that is developed in a constant, ongoing tension between its past and the future, because a computation starts with algorithms and with programs, and both these algorithms and programs, they basically capture past behaviors, and then they try to repeat those past behaviors. But when algorithms and programs are enacted, when the computation is set in motion, irreducibility emerges. And because of this, the computation projects itself not towards the past, but rather into a futural state, beaming the thing that Timothy Morton describes after Derrida as a to-come, a future. So computation also unfolds into space, and we have a deeply spatial relationship with computation, but we'll go back to that later. So, at a time when computer systems, computer media, and computer tools are so ubiquitous, we cannot define computational arts just because, somehow computers are used or are present in their production. Because if we did define computational arts like that, most arts, this definition would be all-encompassing, and so it would be pretty much useless. So the mere presence of computational systems within an artwork or within its process of production is not enough to define a computational artwork as such. Rather, I think computation itself should be fundamental for the artwork's creation or for the artwork's deployment. Computation itself should be a meaningful element in the artwork, and it should be an aesthetic output of the artwork. So there are a plethora of alternative terms to describe process-based art, such as digital art, software art, generative art, computer art, algorithmic art, etc. And several people have tried to clarify this terminology with mixed results. So let's propose a definition of computational art then that emphasizes computation as an aesthetic relationship. A definition where computation is not used as a tool, is not used as an infrastructure, but where it becomes inextricable to the work, to the artwork. Computational artworks are therefore systems, and much in the same sense as Jack Burnham's An Object, in the systems aesthetics of the 60s, they are post-formalist. They are developed from a systems viewpoint. And this means that more than highlighting form, they value the development of ongoing relationships and derive from these ongoing relationships whatever aesthetic value they have. So a computational artwork doesn't so much create artifacts as it creates environments that emerge from a network of interacting components where humans may play a role, sometimes a fundamental operational role. So there's a lot to say about computational art and about our experiences with it, but of course our time is limited, so I'll quickly highlight a few of the factors that to me seem to be fundamental for understanding the uniqueness and the idiosyncrasy of computational art. The first of these is, of course, technology itself. This is the one that computers and computational media carry with them naturally. We can also speak of mechanization that sometimes is used as a synonym for technology because of its seemingly omnipresence in modern technology. So computation is the central technology of our time, and its emergence in our world brings a massive shift in paradigms, from problems of intensity, substance, and energy, which were the industrial problems, to problems of structure and organization, information and control, which are the post-industrial problems. So technology is a force that has drives, that has inputs, that has drives, that has wants. Let's put it like that. And these drives push technology, and we humans are taken along with it. This is why Manuel de Landa, for instance, talks about the idea of a mechanic phylum, getting inspiration from Deleuze and from Guattari, to designate an independent evolutionary track for this, cauldron of non-organic life that includes many, many things. It includes, quoting or paraphrasing de Landa, flows of lava, biomass, genes, memes, norms, money, and other stuff, Because technology is a very large and ongoing accumulation of invention and of creation that we almost could alternatively describe as culture. Because, by bundling together the technology, the techniques, the products of technology, and our own products with it. So we have always lived with technology. We were the source of technology, but we were also one of its products, because we are quintessentially technical beings, in the sense that we have emerged with technology and through our relationships with technology, from Flintstones used as tools and weapons to genetic and cultural algorithms. So technology, starting with fire and starting with language, has always extended our bodies, as Marshall McLuhan said. It extended our senses, and it extended our cognition, causing deep and permanent changes in our nature, and saturating our lives and our institutions and leaving, nothing untouched in its wake. So through technology, we overcome our bodies and we overcome our finiteness. We dilute the frontier between ourselves and the rest of the world, actually, as the environment, with all the technologies that are present in it, and I'm looking at a place with a lot of technology, as this environment plays an active role in driving our cognitive processes. So we exist in this intimate relationship with technology, and technologies do not operate on matter alone, but rather, on algorithms and on complex infrastructures that can be simultaneously material and immaterial and symbolic. And our actions within this, relationship result in a unity where we do not work with technologies, but we almost play against them. We become entangled in this relationship where the technology functions as a function of the human or of the human's intentions, but these intentions, on the other hand, exist themselves as a function of the technology that is available. So this, in the end, is how we have always created art. We created art, or we create art in a tension between ourselves and our technologies. In an ongoing process that tries to probe these limits, tries to question and to discover the similarities between humans and technology and the differences between both, and mostly tries to probe the humans themselves, or ourselves. So the second thing that we need to have present is the idea of language. And language was, of course, our first great space of signification. It was language that allowed us to expand ourselves from Earth and from our inner selves. And it's interesting because, it's plausible to date the development of language to the same time period as when we started developing the technologies for producing images, for producing pictures. Images are a technology for showing, technology for seeing. And much like language, and McLuhan would say much like all our technologies, they are technologies for making metaphors, to translate our experience from one form to another form, to get it out of ourselves and to give it some material existence, or to just put them in the head of someone else. So all technologies are then, to a certain point, equally verbal in their structure, and their products, whatever they are, speech, text, pictures, artifacts, the products of technology are never discrete entities, but they are always part of complex networks of production on one hand, of perception on the other, and of creation of new technologies and science too. So technology breeds technology. And language and pictures are both things, to communicate information, but also to make us understand the world. So images, for instance, are not only a technology for showing, but they are, a technology that shapes vision, that makes us look in a particular way. So language is also central to another thing to another trait that is uniquely human, and that is the idea of storytelling. And the construction of narratives, a way of dealing with, we do this as a way of dealing with uncertainties and with ever-changing contexts and ever-changing surroundings in our lives, and storytelling, or the creation of stories, allows us to reconstruct previous actions, to remember them, and to use and to structure autobiographical memory. But it also allows us to anticipate future events, to simulate them, to visualize or imagine them. So the technology of language, or language as a technology, gives us a tool to describe the world, to create these models of the world, but it also has the power to affect the world and to change our reality. So, and why do I talk about language? Because computers, and particularly digital computers, they operate in this domain of language. They were born, if you look at their history since the 30s, computers were born from an intersection of attempts to come to a mechanical account of language, to explain language from a mechanical point of view, intersected with attempts to provide a linguistic account of machines. So digital computers are in reality linguistic machines that actually manage to be very effective at manipulating numbers as one of their many domains of operations. But more than being number crunchers, as we so often see them, they are first and foremost language machines. You know? So at the same time, they end up treating language as numbers and as logic and as pretty much anything else, you know, with an odd combination of practicality and philosophical abstraction, you know, that inevitably shapes our own human language in the end. So the other aspect of language that is very relevant when considering its relationships with computation and with computational aesthetics is how language operates in this liminal space between reality and the description of reality and the construction of reality. You know, human consciousness, our consciousnesses, they run on information and they develop, you know, a model of the world, a simulacrum of the world, or a virtual reality, or an interface that allows us to negotiate with the world, physically and mentally, of course. It allows us, in the first place, to monitor our bodies and to monitor our behaviors, predicting our own behaviors and the behaviors of other animals and other humans. Now, to do this, we use representational systems and we use signifiers as stand-ins for other things, you know, and these signifiers actually work in the absence of other things. You know, they allow our memory and our imagination to call to mind things that are neither present or sometimes don't even exist at all, that become real because we imagine them. So computational systems are also, you know, world-building systems. They also have capabilities of virtual reality, and our relationships with these computational systems are also strongly marked by this mutual capacity. We are very different, but we intersect in many interesting ways. You know, and then procedurality, coming to the end of this list of affordances, is, you know, the central feature of the digital medium and of each of the many, you know, computational technologies and tools that form it. Computation itself is more than any other aspect what defines computers as such, you know, and what makes all other affordances of computers possible. You know, procedurality is then the system's ability to execute the rules that I started to speak of. It's the system's ability to take inputs and to differentiate, you know, if we're talking about a digital computer, to differentiate between what in those inputs is data and what in those inputs are rules, and then to change its own state consequently. Now, procedurality is the operational aspect of computation, where rules are declared, where rules are followed, where they generate behavior, and where the creation of meaning through, you know, the interaction of algorithms actually starts. And then, because of procedurality, interaction brings, you know, participatory aspects to computation. You know, it allows the development of, you know, what we may describe as a structural coupling between us, humans, and computational systems. So the idea of interaction has been associated, mostly in computer sciences and engineering, with the possibility of a system accepting user input while the program is running, of course. You know, something that certainly seems trivial these days, but that was far from being the norm until the 60s, maybe early 70s, you know, when computers tended to be preloaded with data and with programs before setting, you know, being set to process their outcomes. So interaction is what happens when computational systems and humans compute at the same time. They compute in tandem. They become entangled in the computation through whatever interfaces are available for that, and that allow information to be exchanged between computers and humans, or, if we want to generalize, between any computational systems or between any systems. Interaction may, of course, be developed between two different computers, two or more. But what's interesting here is that it was only when interaction became possible that computers became more than problem-solving machines. They became more than just big and fast and very powerful number crushers. And they became, because of interaction, into something that is far more consequential, which is they became problem finders. They became problem explorers that allow us, humans, to survey conceptual spaces with such a complexity that we are not, we are not able to explore them in any other way rather than through computational machines. So interaction is then one of the central processes for the creation of new information in computational systems, and along with procedurality, it is a contributing factor for the inherent instability of computation and of computational media. It actually leads to all media becoming programs that, permit the activation of variants or alternatives in their latent contents. And therefore, in the current regime of computation, interaction is not only possible, of course it is, but it's actually almost inevitable. Interaction seeps in all computational media, even when we try to avoid it. So the potential for interaction, or the realization of interaction, unavoidably transforms all computational media forms that intend to replicate, the linearity and passivity of what we may call classical or an analog media. And this has, in its turn, serious consequences on these media's experience and in culture at large. So, however relevant interaction is to computational aesthetics, we need to stress that computational aesthetics is not exclusively an aesthetics of interaction. They may intersect, and very often do, but computational aesthetics doesn't necessarily have to include interaction. Firstly, because of what we may describe as vicarious interaction, what happens when I watch someone interacting with the system instead of interacting myself. But mostly because of interpretation, because the set of procedural actions of a system that may be independent of interaction. Because this issue of interpretation is where computational aesthetics actually hinges. And this is all the more important when computational systems are not interactive at all, or when they are not transparent to the reader, when they become partial or total black boxes. The process of how we discover what a computational system does or how a computational system does, which is more important in the case of computational art than what it does, is actually central to the aesthetic experience. So we may say that the hermeneutics of computation depends on direct interaction whenever direct interaction is possible, but it also depends on a cognitive and epistemological interaction between the computation and the reader. There's not only the giving of meaning to the computation through our interpretation, but also the actual construction of computation through the act of interpretation. And this is from where the epistemic potential of computational art arises, from this oscillation between flow and distancing, aesthetic distancing, and between action and reflection. And this is developed in the aesthetic relationship with computational artworks, in the becoming part of the work and sharing the computation of the work, at least for the duration of our contact with them. So, as a consequence of procedurality and of interaction, art becomes something more than merely a recording of somatic actions, or it becomes more than merely a recollection or a representation of those actions. Art becomes something doing something. And the computational system working is always teeming with action. Although, admittedly, much of it can be quite invisible, and it hides away in the black box of the subface. But in spite of this and of its varying visibility, action is prevalent in and as its manifestation, behavior becomes one of the definite characteristics of computational media. And we are thus also able to speak of an aesthetics of behavior. A direct consequence of this is that art, or computational art, becomes increasingly based on an event-oriented aesthetics, instead of, as in modern art, an artwork or an object-oriented aesthetics. As processes manifested through behaviors, we also understand behaviors themselves as encoding processes and as encoding meaning, as organizing our own time, our own space and our own operations. And therefore, we increasingly value them aesthetically. We are taken back to how culturally and socially significant rituals have been in organizing our own behaviors, and wonder how that fact may actually contribute to how we currently engage with computers and with computational systems. So finally, behavior leads us to an approximation with the aesthetics of performance, particularly with the significance of using playfulness as an element in artistic practice. Because play is a very strong force for engaging audiences, because it touches in some primeval human psychological and emotional spots. And the tension between the ludic on one hand and the aesthetic on the other becomes a driver for experimentation with the boundaries of art and the boundaries of the artwork. So, computational systems are algorithmic signs, to use Friedrich Nacker's description, that exist in a duality between a surface and a subface. We are only able to deal with algorithmic signs if we consider them to be this structural coupling of a sensual and analog surface with a digital and manipulable subface. The surface is what we see, what we feel. It is, of course, a part of the computational system, but at least in digital computers, it's not the computation itself. The surface is indispensable to communicate with us and with other organic and mechanical systems, because we are, after all, analog beings, and whatever signs are destined to us must be encoded in analog forms, otherwise we can't access them. The subface, however, is what drives the surface. It is the system of rules and the system of agents that generate and manipulate whatever we perceive. The subface is the computational. It is where processes and computation are deployed, and where we find the tension between self-perpetuation and completion, between the effective procedures that are programmed and that end gracefully with the spirit of universal computation. So the subface is by its very nature invisible, at least in modern digital computers. What happens at this level in the processor, in the memory banks, anywhere else, really in the innards of the computational machine, happens at spatial and at a temporal scale that are too far removed from our own scale and from the limits of our senses for us to be able to perceive. So the subface becomes a black box to which we cannot have access, direct access at least. We may study its code, we may study its programs, but code and programs are actually not ontologically equivalent to computations themselves. So the only way we can peek at the surface is by going through the surface. And finally, we can point to ergodics. And this is a concept that focuses on the feedback loops that we establish with the medium, with the computational medium. It focuses on the flows of information and on the actions, both from me as a reader or a user or whatever we may call it, and the computational system. And how those actions contribute to create information. So during the engagement with the computation, readers develop a semiotic sequence that is very different from those things that we usually describe as reading, actually. This semiotic sequence is constructed through a sequence of selective movements, and of actual physical work that requires a non-trivial effort to construct the actual things that we read, the actual information and signs that we read. This traversal, to use the term that Espen Aarseth uses, this traversal of the topology of the work or of the computation is the ergodic process, is the process during which that very space is brought into being. And this is what qualifies as ergodics. It's a level that produces signs by means of performance, our own and the computer. And it's a level that is concurrent with the semiotic level, where those signs are then interpreted. So, coming to environments, our experience of space has been mediated and transformed by computation, as everything else, I guess. And this has happened both in actual physical spaces that are infiltrated by computation as in purely virtual spaces. Both these environments have become hybrids of actual objects in the world and computational objects. They become an amalgam of the natural, speaking of sound, they become an amalgam of the actual acoustic environment, the geophony and the biophony that Bernie Krause talked about, and of classic sounds produced by humans, with sounds that are produced and experienced through computational systems. And this last set of sounds has a very particular set of affordances that significantly impact the soundscape, especially when we conceptualize it aesthetically. When we think of soundscape as how environments are understood by those that inhabit the environments. So, our environments are hybridized with computation in four main ways. On one end of the scale, we have fully computational algorithmic environments. This is the space of, headset, virtual reality, and things like that, or of the matrix, if we want. Then progressing towards, physical reality, if we want. We have what, Kitchen and Dodge call of code spaces. And these are spaces where we find a parity between the virtual or the computation and the built environment and the daily experience. They are balanced, and to the point where computation becomes so crucial that the actual environment and the experience of the environment ceases to function if code is not there. Think about an airport, for instance, and how an airport ceases to be an airport if we remove computation from it. It may not function at all. Then we have augmented environments where we find an overlaying of computation to the actual world, where computation coexists with the physical in a variety of articulations and hierarchies. And this is, I don't know, the domain of augmented reality, but it's also the domain of many of our everyday experiences with, our laptops, our smartphones, and our computational devices. And lastly, we have what we may describe as offline environments. But even these offline environments in our, post-internet and post-digital world are also touched by the effects of computation. If nothing else, they are touched by the cultural effects of computation. So those environments that we conceptualize as offline are also subjected to the effects of computation in this condition that has mostly turned all our culture into yet another code space. So what all of these environments have in common is computation. Within them, computation is not only used instrumentally, but becomes essential, whether or not it's experienced as such by humans or other agents within the spaces, within the environments. Inevitably, as it happens in media, that have been absorbed by or displaced to computational systems, these environments are also significantly transformed by computation. They become a plastic and protean digital medium that now encompasses most of our living and working environments. And when media became computational, they continuously started breeding new media. When environments become computational, they also start breeding new environments. Like much in the same sense as media became metamedia, computational environments then become meta-environments. Meta-environments that develop across multiple and arbitrary forms and multiple and arbitrary modalities. Environments that are expanded by computation and that become more than a space-time where agents exist. They become themselves agents. Environments become machines in operation, machines that act, that process, and that generate information, and machines from which computation emerges. They are ergodic and they are interfaces. And more than just being places, they become platforms. As they become, as meta-environments become ubiquitous, they start transcending our own perception. And as it turns increasingly difficult to avoid interaction with them, the more difficult it conversely turns out to understand what our role is within these environments and what are the particular couplings that allow for the production of new science, of new information, and of new knowledge. So, as computational spaces become pervasive and immersive, they also become progressively more acoustic and more concrete. They almost fulfill McLuhan's foretelling of a transition from visual to acoustic spaces, and they become holistic and they become qualitative. They start breathing these very complex topologies that embed and envelop all outputs that are produced regardless of the modality of the outputs. They're not multimodal, they are amodal in the first place. So in these topologies, then, sound is often relegated to a role that is subordinate to visual media, as so often happens. But sound is resilient and is pervasive, and then it seeps in as, in many different ways. It may seep in as traces from interaction, for instance, as, mechanical keyboard sounds, taps on screens, stuff like that. It also may seep in as designed artificial interaction sounds, such as, the keyboard clicks on mobile devices or other elements of sonic interaction design. But it also seeps in, finally, as sounds produced by the hardware itself. Refrigeration fans on computers, electric hums, things like that. At the same time, computation starts listening to us. As sound becomes to be commonly used as a medium for interaction, systems need to start listening to the sound we produce and to the sound that exists in their environments, better said. So we start also discovering the presence of what we can call operational sounds. Sounds that may or may not be targeted at us, sounds that make part of a process, but they are not necessarily an output of the computational system that is targeted at humans. So, in order to be able to operate and to navigate in these environments, we need to read them, and to read them in order to deduce procedurality and to deduce computation. And as sound becomes a part of this, it also becomes a fundamental part of the process of reading computational environments. A process that needs to go beyond the visual and beyond the spatial to embrace the acoustic and the sequential. So more than hearing to computation, we need to start developing listening as a skill and to reflectively listen to computational environments. We need to engage with computation in acts of active and participatory listening, because we inhabit these environments, we listen to them, we move in them. And listening is, of course, never static and is closely related to movement in the mechanics of sound perception and sound production. But on the other hand, what does movement mean once we find ourselves in an environment that transcends physical space? If the presence in actual environments can be passive, not entailing acting on them in any way, when we find ourselves in one of these computational meta-environments, we find ourselves in a context of constant acting. We find ourselves in a place where action is always existent. So we conceptualize these computational environments in spatial terms because we do. That's what we do to most things. That's how we think. So we attribute to them particular geographies, particular toponymy, and, well, it's not by chance that we talk about information architecture, for instance, because we think of these things spatially. And this is more than a conceptual issue, because when we interact with a computational environment, what happens to us is causally linked to the computational events going on. The outputs of these events are not simply, recorded signs of the past, as would be the case with classical media, but they are actual events that are happening here and now. They are happening to you while you witness them. They are real-time events in a particular space-time. They are not analogous and interchangeable. Well, we could use a very popular word these days and say that they are not fungible, but they are always very concrete and very, very concrete occurrences that happen here and now to a particular person that interacts with the system or to a particular system that is computing. They are futural, therefore. In interactive systems, we may posit that humans become an integral part of the computation and that their somatic topologies become part of the topology of the system. And this ends up partially embodying computational systems because we find that their space enmeshes with the space of the human in this ergodic superposition of actual and virtual, where algorithms and code and computational machines are as relevant as human interaction and as human speculative imagination. And in both virtual and actual environments, the role of the reader as a participant that actively navigates and modulates their own experience of the soundscape is key, is fundamental. So We have been studying the inference of computational processes from the reading of artworks in an effort to understand the uniqueness of the aesthetic relationships with computation, and also of the poetic affordances of computation. So, as I said, computational environments are time-based. They are contexts for composing events in time, regardless of whether or not actual sound is used. So, therefore, perhaps listening should not specifically emphasize the modality of sound, but rather also the perception of time-based processes and other transient phenomena that become key to reading computation. As such, listening can be used to understand the processes of the computationalization of environments and to develop interobjective relations with them. So one of the ideas we worked on was that of using methods of sound walking as a form of actively engaging and actively participating with the meta-environment, as a methodology for the active interpretation of this meta-environment. And why did we do this? Because sound walking places the listener in the environment, in this case in the meta-environment, and makes the listener become part of the soundscape. So it contributes to the development of this heightened awareness of sound making, but not necessarily your own sound making, but sound making in the environment. Of all sound making you have access to. So with sound walking, the act of listening becomes very ecological, and the conceptual framework of sound walking is an effective resource to think about our actions within meta-environments, and also good methodology to understand the type of augmented and spatial listening that incorporates actual physical spaces and virtual environments. So listening can be used to explore and to interpret meta-environments, especially if it takes the form of what we can call of computational listening. A type of listening that emphasizes computation, that emphasizes procedurality, that emphasizes causality. When we inhabit meta-environments, we enter processes of making hearing, that we enter processes that allows us to develop retroactive loops between our gestures and our actions and the auditory perception that we have of their consequences. We engage in processes of that we can describe of just-in-time composition. Processes through which we try to make sense of experiences, where we are conflated with computation, and we are structurally coupled to the meta-environment to produce new aesthetic objects that will, in their turn, produce new experiences. And sound is an increasingly important component in this. Sound may act as a main driver, as a fundamental medium to the development of the computational systems technological Umwelt. Computational listening then encompasses the spatial and the temporal boundaries of meta-environments and is a hybrid of human and computational operations. It becomes interobjective, really, with our here being guided by logic and being guided by technology to navigate through the computational, trying to hear as the computational. Thank you.
Thank you, Miguel, for your amazing presentation. It's a lot to process. Before pass the conversation to our virtual place, I'd like to I was wondering what was the first drive to get into this subject. So how this notion of computational aspect of the art relates to you as a designer, as an artist, as a creator in general, as an art consumer. Yeah.
Well, it's a long story.
Okay, the short version, please.
No, and it's a long story because, a bit like you, I guess, my generation was the generation that was brought up with computation on one hand, and then that discovered computer tools, right when we started college. At least in my case, the computer revolution in design, at least in Portugal and in Porto, happened while I was, doing my undergrad. So computers became, in a matter of a few years, they became this omnipresent tool, the tool you could not dispense with. But a tool that was mostly used to imitate other tools. And that's still the case most often. You use the computer as something else. You use the computer as, I don't know, a typewriter, or as a multi-track recorder, or as a piano, or as, a photo camera, or as something else. You use it to imitate another system, which is fine. It's great. In most cases, that gives you speed. That gives you economy of means. That's fantastic. And it gives you versatility because, it's a universal machine, so you can transform it, from a slide presenter into something else. But what over the years in my practice, both as a visual designer, but then also as a musician and an artist by way of sound installations mostly, what I started discovering and exploring was that the computer was something else besides that, or beyond that. It would be, I could describe it, or I did describe it in the past, sometimes as an engaged partner, as a creative partner, or as a creative tool, as something that was in between me, or me and the people that were, performing somewhere, and the actual performance. Something that was contributing to the performance in a way that normal instruments, that exceeded what happened with normal instruments. Something that could have agency. And that agency could be creative, right? A traditional instrument is never creative in itself because it's passive, or most of them at least. An aeolian box is not passive. Well, it is because it's the wind that does the work, not the box, but anyway. And that's why I started, some years ago, or many years ago, that's why I started becoming more attuned to what computation was doing in the midst of all this. Because it's not the computer itself, it's the processes going on inside of the computer. And how that becomes, how computation becomes a means to develop tools that are, I don't want to call them smart, because that's not the point. Tools that become, agential, that become creative, or that have some creative potential. And at the same time, because you do that, when you look at computational art, be it, sound art or music or just, visual art, you start finding out that there's something there, something that is aesthetically significant in your relationship with the artwork that does not exist in non-computational art. There's one type or several types of aesthetic relationships that you develop with an artwork that are unique to what we may call computational art, as a broad umbrella, that, a catch-all term that includes all of these, multiple formats and multiple shapes. And that is exactly those processes. Computational art, as form, of course, as, visual or sonic form or any other form, but it has behavior besides form, and it has behavior in a way that is contingent and that is somehow autonomous from you as a reader or as a viewer, but also autonomous to a certain extent from the other human that created it. You know, computational art, if you want to conceptualize, I think I can put this in a different way. A traditional artistic object, whatever it may be, and we can, you know, this is valid for a single image, but it's valid, you know, to a movie, or it's valid regarding a theater play or an opera. You have the artistic object existing as a mediator in a relationship between the artist and the viewer, or the audience, or the reader. You know, it's a mediator in this intersubjective relationship between author or authors and viewer or viewers. With computational art, the artwork becomes an agent too. It's not simply a mediator. It's something that has a different role in this relationship between the creator or the author and the reader. It turns the relationship into almost a triangular relationship because of the agency of computation.
So do you feel that the creator lost some role or some aspects of his normal role in this new engagement? Or it's not about it, it's about a new way to engagement?
That's the usual way of putting it. You know, authorship or the authority of authorship is lost. Yeah, it is. You know, the modern authorial authorship is lost because as a creator, I cannot, you know, I cannot have a precise control about everything that's going to happen, as I do with traditional media. You know, and of course there's always open works, and there are always, you know, unpredictable events. But at least in theory, the ideal of traditional authorship, let's call it like that, is absolute control, right? What happens with computational art is that the author needs to abdicate from that. It's part of the process. You can try to have absolute control, and to a certain extent, you can have more control than with classical media using computation. But in that case, you may argue whether you're doing computational art or if you're just substituting, you know, traditional media. I think that you actually, as an author, you actually gain instead of losing. You gain because your role becomes more complex and your poetic affordances become far wider.
My question, it wasn't about of losing control, because I think we passed that issue. But in some way, I feel that the computational art, it's now a little bit a mediation between the viewer and the process. So the author, I think it's in a very interesting place, but now it's more decent to the viewer.
Yeah, yes and no. I think that, you know, we are humans, so we cannot avoid anthropomorphizing our experiences, right? That means and also we know that there's no such thing as, you know, general AI. So we know there's always a human creator at the other end. You know, things don't create themselves. Things can create other things. You know, you can talk about meta-creation, for instance, which is the process where instead of creating something, you create something that creates something. But you know that ultimately you always have a human in the loop. And that really informs the relationship you have with computational art. You know, as with all art, you always think about what are the intentions of the person that did this. Am I thinking about this in the right way? Because what was going on in the head of whoever devised this, even if you don't know who they are, you know? So that means that the biographical details of the author are not relevant per se. They may be if you know them, but what's relevant is that you know that the author is human just as you are. So there's this set of expectations, there's this set of, you know, cognitive, well, let's say, I don't want to call them normal, but this expectable cognitive reaction to a work that, you know, most humans have. So that kind of fine-tunes your relationship with the hypothetical human that was on the other hand, and that had the original, let's say, artistic intent.
I can't resist to I have another question.
Go
So
on.
I was, during your presentation, I remembered an article that you wrote with Rui Penha.
Where we talked about this kind of things.
And so, do you think that if art is happening now in this subface level, art or artistic expression can still happen in a non-eligible place for humans?
In a non-what, sorry?
Illegible. It's obvious. The question it's wider. It's about motivation and.
I think, if I well understand the question, I think that there are things that cannot be reachable by humans, that cannot be, read, understood, figured out, or perceived by humans. And that's a big part of the things that go on in a computational system, and that's why they are mostly black boxes and they only show us some things through their interface. So, yes, there is a lot that we can miss, but I don't think we can talk about art in that space.
Okay.
Art is always about, I think, art does not exist without humans. Art is a way of humans confronting themselves through their technologies. It's not, art does not happen, does not happen in the absence of humans. Art is not an object, I think. Art is a relationship that you develop with an object. And because of that, whatever is inaccessible to us is not art, or can't exist as such, while it is inaccessible from us. What do I mean with this? For instance, if you think about, so when you talk about computational art, you have this, duality between a subface where computation happens and a surface where, sensorial things happen and perceivable things happen. So between, if you want to simplify this, between the CPU and the memory and whatever output the system has. And these two always work in tandem, hand in hand, so to speak. They are coupled. Of course, you can think about an hypothetical system that only has subface and has no surface at all. A system that is computing, doing really interesting computation, but has no physical sensorial outputs. That system is a total black box. That system is as good as not existing in the world as an artistic object, or as any other object for that matter, right?
Yeah, I'm thinking if you, as a viewer, you don't relate to, you don't have a surface, you don't have a sensorial connection, but you can enjoy knowing the process, knowing.
But then you have a surface. Then you have information.
Okay.
If you have, let's say that you have this. Let's say that you have this box, this black box, where you know that something is happening. Where you're told that something is happening. That information is already surfaced. That is already giving you hints about what's going on inside of the box. When I talk about a system without a surface, it's a system that you can't even discover because there's nothing to be discovered.
So we can't imagine art expression without
information.
Yeah.
Some sort of communication between the system and us. Whatever it may be.
Cool.
Right.
Thank you, Miguel. I think now I'm going to open the conversation to our virtual place, and we know the usual. Diogo Tudela wants to participate. Diogo?
Wait.
Hi guys, how are you?
I think I have this off.
Sorry,
Diogo.
one second, Diogo.
Sure.
Oh, please go on.
I think you are on. No?
No, wrong channel.
I really don't.
Nope. Whoops.
You can go over there.
I can.
technical problems.
I'll sing a song now.
No,
No, please don't.
you are on now.
Okay, can you both hear me well?
Yes.
Yeah.
Yeah, okay. So, hello, Miguel. Hello, Joseph. Thank you both for both the presentation and the introduction. Miguel, I think I have a couple of bones to pick with you.
No,
That's okay.
by all means.
Yeah, so I'll choose one. I think I have some doubts on your position regarding surface and agency, but I will start to ask you for a certain clarification on, even for our students, on the entanglements between your view of computation not being anthropocentric or may not be anthropocentric and universality. Because I agree that thinking or thoughts, well, is an outcome of a sociality as the act of rendering something intelligible. This would be like the core of the Hegelian Geist, right? But this would be, I guess, a mechanism that yields the possibility of computation and not the other way around. And in that, the act of knowing a world or to compute a world would entail the construction of such world or to render a world computable, a world built by the human as a human. So such process would be, I think, an anthropocentric tactic. It's in itself a manifestation of locality. So how can such epistemological model be overextended to any form of universality?
Well, you're referring to the second sense of universality, right?
Yeah.
So the sense in which we may, I need to take this off because otherwise I can't speak. So the second sense of universality is the one where we can think, is the one actually derived from Stephen Wolfram and from all the work he did in computation. And this proposal of this idea that computation exists as a natural phenomenon. That computation may be, and he has been doing a lot of work on that since the 80s really, but more recently since last year where he started publishing a lot about this idea of computational physics or computation and physics. But his main premise is that we can think about many, if not all, natural phenomena as being driven by computation, as being computational themselves, you know. It doesn't, of course, give us yet what are the rules for that computation or for those computation, what is the particular program or a particular algorithm for, say, our universe or for string theory or for any other thing. But it defends the idea that we can study most natural processes or all natural processes as computations themselves. And what happens here, you know, I'm not going as far. Of course, I could say that yes, it's world building because of this, and the world that is built is our own world. But that was not exactly what I was saying. What I meant is that whenever you have a computation, any computation really, be it simple or complex, that computation creates a space, a phase space, that is a world where events can happen. This is, of course, metaphorical, but it's not so metaphorical as it may seem. Because, you know, when we talk about world, what are we talking about? We're talking about a space-time where events can happen. A space-time that creates an horizon of possibilities or a phase space of possibilities where agents may exist. Agents and objects. They may be the same thing, and where these things can interact within a given set of constraints. That's what happens in our actual world. Granted, it's very complex, and the set of constraints is not as narrow as that, but this is what happens inside any computation. I don't know if Diogo is...
I'm still here, yeah.
Oh, you're still there. Yeah. Okay. I don't know if this answers your question.
Well, partially it does. So I think I'm going to leave for the students now. I think that now you mentioned a sense of world building, and I think one of the main or the one of the most interesting outcomes of this notion of world building is actually that world building would usually entails in a lot of different discourses from Alaa Baidu to Nelson Goodman or actually the idea of pluriworldism. So that's my problem with the term of universality is that having a world or having worlds, we could drop the universality out the window or the real out the window as a concept. But maybe we could discuss this in the future. We have students and they pay tuition, so I'll stop preloading.
There's a
Thank you very much.
somewhere. Okay, thank you.
I don't know if anyone else wants to make a question or a comment. Please don't be shy. And if you need to speak in Portuguese, Miguel understands Portuguese very well. Okay. So we are passing the hour, so it's okay. Miguel, thank you very much. I think we have to still continue to follow you in this subject. And I advise everyone to take a look to your work, to Etsy work, and to Chronicle label. It's a very important label in Porto artistic panorama, but in general, the industry in general. Remember that next session will be on the April 15, and I'm expecting a lot for that session. It's with Steve Goodman, also known and mostly known as Code 9. It was a reference for me in like 10 years ago, and he still is as a musician, but he has a lot to say, and the theme for his presentation will be audio virology. So thank you, Miguel.
Thank you.
Thank you all, and see you next week.